I want to introduce something, Bill, here. I'm going to introduce us. We're doing, this is the second in the series of
What's inside?
What's Inside.
Right.
And Bill here is a machinist. He's worked in the industry his whole life. And I'm an outboard mechanic, and I've been an outboard mechanic pretty much my whole working life, with a few stints here and there, and the same thing for him. So this is, we're talking about these engines and the innovations that took place, and looking at the actual stuff inside that made it happen.
Right, so Lincoln has this great end-user view of this whole industry, and I have more of the manufacturer's view of this industry. So we have, Lincoln has seen some really horrible broken stuff that he's had to deal with. And of course, all of us, restoring antique outboards, we've all had some horrible things to have to deal with. But anyway, so we're here in Waldoboro, Maine, and we're going to talk about the next engine we're going to talk about is this great Johnson model V45, which is quite
Lurking right behind Bill.
yeah, right, working. And so it was, 1929 it was introduced, and it was quite the sensation. Because it was so very, very different than what the industry had already produced. Even Johnson itself, throughout the 20s, had their whole lineup of outboards, starting with the light twin, through the standard twin and the big twin and the giant twin, basically all looked alike, and they were not so innovative in design. They had that square steering rail, and they were a 3-port engine, with their wonderful quick action magneto.
Should we take a quick look at some of those?
All right, yeah.
What
Yeah,
Bill's
I-
describing
yes.
is what got Johnson into the outboard business, I think.
Right.
And we'd be looking at probably, this one right here is sort of a premier first big outboard ever introduced, and it's, as Bill said, it's,
Called the Big Twin,
yeah,
1926, I believe. And of course, it's just really a scale up of the Johnson Light Twin.
right here.
And
Isn't that a-
right, yeah,
That's a
yeah.
later
So there's-
version of the same engine
But
right here.
very typical. In fact, if you look at all of these, except that, they all have
That's
this.
the K35, yeah.
Yeah, they all have this scaled up view, design. So,
All right. Get your hands. Yeah, okay.
yeah, but back to the V45, and that was a very innovative, when you look at the whole Johnson lineup from the 20s, the V45 and its smaller brother, the S45, were total breakout from a design point of view, and it's just absolutely amazing to see what they had done with, and I believe it was probably the Johnson Engineering Group that really did a lot of thinking. They looked at the industry, the whole boating industry, and they were pretty stagnant through the 20s, and then they decided that the industry is ready for something really, really innovative, and maybe a little bit inspired by the 1928 Elto Quad, which was really the sensation of the New York Boat Show in January of '28. And I think at that point, Johnson said, we've got to do something. We really have to do something to break out of this, and they did.
Well, wasn't the giant twin, their engine, the Johnson engine, in competition with the Elto Quad?
Yeah.
And the giant twin was, the lower units fell off of them. They were
Right.
huge and unwieldy
Yeah.
and
They were big.
odd. They were very,
They made
very
horsepower.
odd.
Yeah. Yeah. And it was a kind of some things don't scale up very well. Okay. And they start really nice when they're small, and they say, well, we'll just make a bigger one. But there's things that just get lost. And I think
Okay.
that one of them was that this. But the Johnson, that giant twin, did have one feature though that was very beneficial, and that was that release charger. very innovative. Not only didn't it have a valve to open the combustion chamber to vent compression, but it also had a little rotary valve in the bypass port to shut the fuel off going into that cylinder. So it was quite the nice design. And that also is now carried over to the V45 as well. And that's got this, what's called, Johnson called a release charger, which really does, push in these valves in the combustion chamber. But you can see there's a linkage here that
Operates something else in here.
a rod in there, a shaft in there that is cut in such a way that it when it's in this position, it shuts off the fuel going to those cylinders.
Okay.
Yeah.
Can we take a look at that very quickly
Yeah.
here?
So
I think one of these has the bore for the release charger. There it is, right there.
right here.
All right. Is there anything we can see inside that shows us that it had
Well,
valving?
it's,
Okay.
you can't really see.
All right, but it shut off, basically it shut off in here.
Right.
Those
Yeah,
shut
it
off
shut-
the intake,
Right.
period. Yeah.
Yeah.
Okay, very good.
Okay. So let's go inside this. What does this look like inside? So starting with the crankshaft. Crankshaft is just so amazing because the industry at the time had flat forged crankshafts, and this is like a total design innovation for two strokes, and it's what I think people would call a full circle crankshaft. And what that allows the two-stroke engine to have a tighter crankcase because it doesn't have airspace in between the throws, and so it's really quite a wonderful piece of forging and machining and everything.
Again, were these done in-house, do you think, or were they done by an outside vendor?
Johnson was big enough,
To have done everything themselves?
maybe, I don't know that for a fact, but Johnson was a big manufacturer at that
Yeah.
time. And it's actually interesting that Johnson claimed, and I believe that to be true, that the Johnson company made half or slightly
More than half. That's-
slightly
yeah.
more than all outboards produced
yeah.
in 1928,
Right.
1929. So the other half was all divided, or less than maybe a third or something, where production was divided between Lockwood, Elto, Evinrude, Kale,
Yeah.
Cross, Hartford, and Amphion, and some of those others. So they own the last third of that pie. And so anyway, I don't know the answer to that. Of course, there's a lot of talk about Johnson Model V crankshafts, and they tended to have a heat treating problem. And this one's a good example of, I don't know if you can quite see in the video, but the crank pins are pretty chewed up on this example. And amazingly enough, it still worked pretty well, even as being chewed up, because Lincoln
Well,
here.
this one right here, in particular, I think the engine, I had the engine running that used this crankshaft, and when I took it apart, because I had to put a new, I can't remember exactly what the reason was, but I did not set up my two gears well, and it ended up chewing itself, and the gears on these originally were plastic, a form of plastic, but the later ones, when they were refurbished, these engines, they went to a steel one because the plastic wasn't holding up, and I did not set it up well, and it ruined itself, so I had to take it apart, and the water had gotten in on the bearings and rusted in a full needle bearing engine. It destroys itself instantly in a very short period of time. But these cage roller bearings they used on them can handle that destruction that takes place with water in the gas. So here we have a system which, once it was working well, but Johnson did have problems with hardening on these crankshafts, as Bill said, and they replaced a lot of them, I think, under warranty, is my understanding. Because the engines I've all worked on, all of them have been worked on, and cases welded and that kind of thing. So my guess is it was a fairly common problem.
So going with that wonderful crankshaft and those cage roller bearings, were forged steel connecting rods. Previously, the industry standard were bronze rods running directly on, a case-hardened crankshaft. And it was, Johnson actually talked about crankshafts and case hardening and all that. Johnson really did pioneer the use of bronze rods on case-hardened steel crankshafts.
Okay, good. Let's cut that off. I'm gonna stop this one. The battery is